Hey everyone, my name's Alex Catighera, and I'm a software engineer at a company called DailyPay. And we use AWS Lambda and API Gateway to process millions of dollars in payment transactions. Currently we're using mostly Node, but we are looking to start using Go for some of those services. So just to get a little bit of explanation about what Lambda is, it's a serverless service that lets you execute an arbitrary function in the cloud. So you can invoke that function via command line, or you can also have other AWS services trigger your functions. And the example that I'm going to go through in this lightning talk is API Gateway. Another interesting note is that they added Go support recently. This was a few months ago. And to kind of get up and running with this kind of stack, the prerequisites are an AWS account and setting up your AWS credentials in your Bash profile, and then also a tool called Apex, which actually is an open source tool written in Go. And I'm going to go through that a little bit as well. So you'll go to get kind of set up, you'll go into your project directory and run Apex init. And what this will do, it will actually create a few IAM roles and permissions. So this is just AWS's permissioning system. So you can give your function permissions to do specific things. Like one of the things it's doing here is permissions for writing to their logging system. And another thing it'll do, it'll actually create a project.json file, which is kind of like a configuration for Apex and for your Lambda function. And I'll go through an example of that in the next slide. And then lastly, it'll create a functions directory. And the convention that it uses is each function will be a subdirectory within this directory. All right, so in terms of configuration, you'll have a project.json that gets created. It's pretty straightforward. And you can configure things like memory, 128 megs. And like, for example, this one has a timeout of 5 seconds. And you can also specify some environment variables that you may want or need in your function. And also each function itself will have a JSON file, and you can use that to override the project level settings and also set up some hooks. Like for example, this function.json has a hook for pulling down external Go dependencies before building. So let's get into the code. So as I said before, the directory structure is functions and then your function name, and this function is called greet, and then a main.go file. And as you can see, some of the more interesting bits, there is a Lambda package. And if you look at the bottom in the main function, we're calling lambda.start and then passing in a greet handler. So this is kind of the glue code to kind of invoke your Lambda and have a handler. In this example, our handler is pretty simple. It's just a greet function. It takes in a struct with a name and a species, and then returns back a string greeting for that. So once we have our code, we can actually deploy this code to AWS using AWS deploy. It'll create the function using Apex's naming system. So the project name, go meetup, and then greet is the function name. If you already have this specific function, it'll create like a second version. So Apex will also manage versions for you. So let's go ahead and invoke the function after we've deployed it, and it'll return a string that kind of looks like this. This isn't too useful. We want to be able to pass in some arguments. So you can also pipe in some JSON with a name and a species, and then call invoke, and then you'll get the desired string. So obviously this is kind of a very simple example, and it's not too practical. That's kind of where API Gateway comes in. So you can actually use an HTTP request to trigger your Lambda function. And API Gateway is like a full AWS product, so you can do all sorts of things like authentication, API keys, error messaging. I won't really get into that as part of this talk. Something else that's kind of interesting, you can set up multiple stages, which are like environments. So you can set up like a production stage and a QA stage and things like that, and have different versions of your API and your Lambda functions. So in terms of setting up API Gateway, I'm going to kind of gloss over this pretty quickly since it's a little bit tedious and not all that interesting. First thing you'll do is you'll create an API, and after that, since we're building a RESTful API, you'll create a resource and then a post method on that resource. So you'll do that. And then the next thing is you'll configure your integration with Lambda. So you'll have a Lambda function integration, and then you also want to specify a proxy integration. And essentially what a proxy integration does is it passes a lot of extra information to your Lambda function, things like headers, refer, all sorts of other good stuff that you may want to process the request. And then lastly, you also will specify your function name. And in this example, it's Go Meetup Greet API, which is a slight modification on the example that I shown before. So we are going to have to make some slight changes to the code to support API Gateway. So the first thing you'll notice is we added another package for events, and our greet handler will now take in an API Gateway proxy request and send back an API Gateway proxy response. So the first thing that we're going to need to do in our handler now is take the request body and parse the JSON out of it. And if there's an error parsing the JSON, we probably want to send back an API Gateway proxy response with a 400 status code and an error message saying there was a problem with the JSON. And if there's not a problem with the JSON, then we'll generate this response string greeting and send back a 200 status code with the body being that string. And you'll also still need that little bit of glue code that I mentioned before in the first example. And now that we're done with that, API Gateway will give you a URL that you can actually ping. So we're going to send a post request to API Gateway with the JSON that we had before, and we'll get a little JSON message back. So that's kind of the example that I'm going to give, and I'm just going to walk through a few gotchas and tips for API Gateway and AWS Lambda. API Gateway kind of intends you to have one endpoint and one Lambda function. However, this can be a little bit tedious. So what I've done usually is have one Lambda function for an entire stage. So for production, I'll have one Lambda function, and you can set that up using stage variables. Another gotcha is kind of native dependencies. And we ran into this issue when actually we had a utility Lambda function that needed to use pgdump. So you can't really install Postgres in Lambda. So there's a little bit of a workaround here that you can do, which is you can actually run AWS's version of Linux in a Docker container on your laptop and build the library there, and then copy over the binaries into your Lambda function. So that's kind of a cool little trick. And another kind of important tip is Lambda warming. So if you have an API with sporadic traffic, the first few requests that you get are going to take a really long time to process. So you're going to want to have like a few Lambda functions warmed or already started. So for an API, you can actually do this using health checks. So you'll set up your health checks to ping your service at regular intervals. And then I'll make sure that there's an instance of your Lambda function kind of up and running. And another kind of little gotcha is if you're using external services that require IP whitelisting, since with the serverless infrastructure, the IPs are kind of going to be all over the place. You can actually specify your Lambda function to be within a specific subnet and put that subnet behind NAT, and all of your outbound traffic will come from a single IP. And lastly, in terms of connection pooling, it's important to kind of reuse database connections. You don't want to create a new connection for every single invocation of your Lambda function. So you can actually kind of cache them or store them in a variable that's outside the main or greet handler functions. All right, and this is kind of my last slide here about why you would use this kind of stack versus just a regular web server infrastructure. So it's extremely cost effective. It's really cheap to run, especially for like side projects and things like that. And I could even see some medium-sized businesses falling under the free tier. It's easy to set up and deploy. It has auto scaling built in. In terms of the negatives, they're mostly related to flexibility. If your project can fit within kind of the confines of AWS Lambda, it'll work really well for you. But if it doesn't, yeah, you might run into a few things like the limitations for CPU and RAM configurations, and also API gateway is kind of your only option for setting up an API with Lambda, and that has its own set of limitations. And Lambdas have like a 15-minute hard timeout, and also you're kind of forced to use Amazon's version of Linux.